This video is confidence intervals, finding proportions, part 2. Now we had just talked about how to use the calculator rather than using the formula to find the confidence interval to estimate a proportion. So just to remind you, we hit stat, we choose test, we go down to 1 prop z interval, which for many of us will be letter A, so you can actually hit alpha A if you want to get there quicker. You'll need 3 numbers, an X and then an N. X is the number of individuals with the desired response, N is the total, and then you need a confidence level. So just those 3 things, and it's actually pretty quick. This one is a really nice feature on the calculator, a really nice function, just because it requires so little. So looking at example 2, according to the U.S. Census Bureau, 43% of men who worked at home were college graduates. In a sample of 500 women who worked at home, 162 were college graduates. Construct a 98% confidence interval for the proportion of women who work at home who are college graduates. Is it reasonable to believe that this is the same as the proportion for men? So we need to estimate this proportion by finding a confidence interval, and then we need to compare it to this 43% for men. So the confidence interval we are estimating is for the proportion of women. Okay, so we can use the formula, but the formula for this one it always takes a while. So let's use the calculator instead. So we need 3 numbers. We need X, we need N, and we need the confidence level. So X is the number of people with the desired response. So what are we finding the proportion of? It's the proportion of women who work at home who were college graduates. So how many women work at home who were college graduates? 162. N is the total sample. That's 500. Notice X is always smaller than N. N is always bigger. The confidence level is 98% right here. So 0.98. So I'm going to use the calculator. Let me pull that up. Alright, so we're going to hit stat, choose test, and arrow down or up, whichever is easier, to get to 1 prop z. And mine is A, so I can also hit alpha A. You see the little A above the math, and you get should there quicker. Hit enter. You only need 3 numbers, X, 162, oops, N is 500, confidence level is 0.98 or just 0.98. And go to calculate, and it looks like we get 0.2753 and 0.3727 if you round to 4 decimals. Okay, so I have written this out. It's 0.2753 to 0.3727. We can also write it this way, that it's less than P. 0.2753 is less than P, which is less than 0.3727. We always have to write it in sentence format, so we are 98% confident the true proportion of women who work at home who are college graduates is between 0.2753 and 0.3727. Now, the question was, is it reasonable to believe that this is the same as the proportion of men? So what was the proportion for men? That proportion was 43%. So here's the question. Does 43% fall in here? In between the boundaries for that confidence interval? No. That confidence interval estimates the proportion to be between around 27.53% and 37.27%. So what that says is that the proportion can be no higher than 37.27%, which is less than 43%. So is it reasonable to believe that this is the same as the proportion of men? No, it is lower than the proportion. For men. All right. Example 3, ISP quality control. An internet service provider sampled 540 customers and found that 75 of them experienced an interruption in high-speed service during the previous months. Construct a 90% confidence interval for the proportion of all customers who experienced an interruption. The company's quality control manager claims that no more than 10% of its customers experienced an interruption during the previous months. Does the confidence interval contradict the claim? So pause the video and first find the confidence interval. You can use the calculator. Next, answer the question, does it contradict the control manager's claim or not? So go ahead and hit pause, and when you come back, the answer will be up. So you should choose one prop Z int. X will be 75, N will be 540, confidence level 0.90. Your confidence interval will be 0.1144 to 0.1634. You can also write it 0.1144 is less than P is less than 0.1634. The sentence should sound about like this. We are 90% confident that the true proportion of customers who experience an interruption in their high-speed service is between 0.1144 and 0.1634. Now don't forget, they had a question at the end. Does the confidence interval contradict this claim? What was the claim? The claim that the quality control manager said was that no more than 10% of its interval, no more than 10% of its customers experienced an interruption. So no more than 10% is 10% or less. Well, let's check out the confidence interval. The confidence interval is between 11% and 11.44% and 16.34%. So that's not less than 10. That whole thing is greater than 10. The entire confidence interval is greater than 10. So what that means is it does contradict. So it does contradict the claim because the entire confidence interval, I just wrote CI for short, is greater than 10%. It's greater than 10%. Okay? Example 4, health insurance. In 2008, the General Social Survey asked 182 people whether they received health insurance as a benefit from their employer. A total of 60 people said they did. Construct a 95% confidence interval for the proportion of people who received health insurance from their employer. So pause the video and try this one. Okay, so we use a 1 prop Z interval. Again, X is 60, N is 182, confidence level is 0.95. We get 0.2614 to 0.3980. We are 95% confident the true proportion of people who receive health insurance from their employer is between 0.2614 and 0.3980. Okay, so now we want to talk about calculating sample size. So to calculate the sample size for a confidence interval that estimates the proportion, you might recall in a previous video I gave you a formula for calculating the sample size needed for a confidence interval that estimated a mean. Now when we estimate a proportion, you need to use this one or this one if you're calculating the sample size for estimating a proportion. Now the two different formulas depend on whether or not you know p hat. If you know p hat, then it is p hat times q hat times the critical value over M. M stands for margin of error. If you don't know p hat, which most of the time you don't, is 0.25 times the z critical value over the margin of error squared. Both of them are squared. I forgot if I said this one was squared or not. And once you get your answer, you round it up. Round up to the next integer. Okay, let's try an example. Suppose a polling company wants to ensure that their political poll has a margin of error of 3 percentage points or less, using a 95% confidence level. How many voters should the company poll to make this happen? So, because we're talking about percentages, we know it's a proportion that we're doing. So we look, do we know the sample proportion? We don't. We don't know p hat, so we're going to use 0.25 times z over the margin of error squared. Okay, we need to find z, and to do that, it's the critical value. So if 95 is in the middle, you have 5% left over, which is 2.5% on both sides, which is 0.025. So you would do INV norm 0.02501, and you get 1.960 in the negative, but again we drop the negative. M, margin of error. So the margin of error is within 3 percentage points. So you need to write this as a proportion. So 3% is really 0.03. So now we're going to fill in the formula, and we get 0.25 times 1.960 over 0.03 squared. Just want to make sure, do this first. Do that first. Then square it. And then you're going to multiply by the 0.25 last. So we get 1067.11. Remember, we have to round up, because if we only do 1067, that's not enough, because we need this 0.11. So you need to bump it up to the next integer. So 1068. 1068. Okay. So this next portion is a couple different flowcharts to help you decide which confidence interval that you need to use, the z, the t, or the 1 prop z. And also I have another flowchart for which formula you use when you're looking for a sample size. So we will do that in part 3.